Hello students, welcome in our chapter 6 AOD, application of derivative. Students, today we are going to our exercise 6.5 continue, first to all numericals and find out maximum value and minimum values. Yes students, local maximum, local minimum, either global maximum, global minimum. Local value means it is lies on the x-axis and global values lies on the y-axis related points. Yes students, now I today start 6.5 first one. Find the maximum and minimum value if they exist for the first question, 2x minus 1 whole square plus 3. Students, whole square value is known always, yes, always non-negative, either they 0, either they positive. So I not apply a derivative, direct applications. We know that, yes, what you know, every whole square value which is greater than or equal to 0. In every, I will just putting 2x minus 1 and plus 3 as it is. So students, 2x minus 1 whole square, 3 adding on the whole side. So you can get here one of the numerical answer greater than or equal to 3. It means this you are drawing done here 3 and more than side, this side your values is coming. So it is by mistake I draw this. It is all value to infinite, but which side? More than 3. Yes. So my answer is over. Very easy. So fx have maximum or minimum? Maximum not getting minimum. Yes, fx have minimum value is 3. Yes, is 3. At which place 3? So we taking fx 2x minus 1 whole square plus 3. We taking in right down. This 2x minus 1 is equal to 0. X is equal to half. And that half put it here. So students, f of half. Here 2 with half minus 1 square plus 3. It is 0 plus 3. And it means your f of half value at the place of half, it is 3, your minimum value. Your maximum value does not exist. So my answer right at x is equal to half, f of half is equal to 3 is, what's your answer? Minimum value. And that's your over. Here maximum value does not exist. Maximum value does not exist. Here maximum we not define, and students this numerical is done. Here we not operate your derivative rule. It is directly going because it's very easily understanding by this process. Now second one, 9x square 12x plus 2. You know that derivative rule, first derivative, second derivative, but I go into this method. It is first term, last term, and the middle term. This is the last term. I convert last term in perfect square. So students, my last term formula, middle term square, 4 into, what 4 into? First term. And by getting the value, 12x the whole square, 4 into 9x square. So my answer is 12 into 12. Yes, by 4 into 9, x square 1. And other also gone. 4 triza, 3 triza, 6 4za. You getting only last term 4. But actual last term is a 2. So I just write down my fx question. 9x square, 12x plus 4. And extra minus 4. I rebalance. I extra written here plus 4 and minus 4. Now students, it is perfect square. Yes, it perfect square 3x plus 2 and this minus 2. Now look at that. This question and this question is same. Now same process I apply. We know that every whole square term is greater than Now only to subtract it. So students, 3x plus 2, subtract 2. Here also subtract 2. So you getting here one little values for that and plotting on the number line. Students, you properly draw number line always, then you easily understand what you define in this answer. So your value is 3x plus 2 whole square minus 2 is greater than or equal to minus 2. It means here you are minus 2 to the greater side running, it is this side, plus infinity, and here minus infinity. So fx have maximum or minimum? Minimum. Maximum it is increasing up to infinity. We cannot say that. So fx have minimum value is minus 2. Now at which place the minus 2? That I taking again in fx. My question is that 3x plus 2 whole square minus 2. This is only the question. Yes, minus 2. We taking 3x plus 2 is equal to 0. So what is x? Minus 2 third. And this minus 2 third now putting again in this fx. So 3 into minus 2 third plus 2. This cancel. 2 minus 2 again cancel, it is 0. And my answer is what? At the place minus 2 third, it is minus 2. So last I say x is equal to minus 2 third. F minus 2 by 3 equal to 2 is what your answer? Minimum value. Yes, students. And here no maximum value. Because your maximum till up to where we going, that is unknown. That's why I draw properly drawing here. Students, here second question is also happily finished. Now continue students. Question number 3. Fx of minus of x minus of whole square plus 10. Very easy. Again here whole square. So we know that, what do you know? Every whole square term is greater than or equal to 0. Now minus something like it is less than or equal to 0. Inequality change and 10 addition both the sides. So you have here quotient and here your value less than or equal to 10. It means students your drawing is a 10 number and which side is going? Yes, less than or equal to. It is below the 10. This side will just converting my data. Here students maximum value comes from 10, but minimum value we cannot say. So fx have, yes, fx have maximum value is 10. Minimum value does not exist. That's I say. Now at which place? So very easy. In fx, my question is x minus 1 whole square plus 10. Here we take the 0. Yes, we take in minus of x minus 1 whole square equal to 0. Surely you can get x is equal to 1. And that one you put in here. So minus of 1 minus 1, you get 10. So that's your conformly maximum value at each place x is equal to 1. So at x is equal to 1, f1 is equal to 10 is our maximum value. And students, your minimum value does not exist. Same now I am moving ahead to next one, gx, x cube plus 1. Yes students, x cube graph you know that it is a cube only passing through 0. Yes, square that I have taken, but cube then we go to our method. Step 1, z dash, z double dash. Students, I is going now our proper device. Yes, here 3x square and here 6x. Good idea. Now step 2, But 3 never 0, students. So you have to only x becomes 0. Check. X equal to 0 in the double test. They are positive value or negative value. That's your step 3. So in G double dash x, I just put down there G double dash 0. Yes, students, we cannot say it is positive or it is negative. It means your maximum and minimum value does not exist. Therefore, GXL maximum or minimum value does not exist. Again repeat. If you getting here greater than 0, then minimum value. If you less than 0, then maximum value. But they not say you are greater than 0 or less than 0. It is exactly 0. Therefore, we write down here minimum and maximum value does not exist. And here, students, this numerical is done. Now, students, we are going ahead. One more same parallel numerical. Question number 2. Find maximum and minimum value of the given functions. Yes, if there exists. Question number 1 modulus related. Question number 2 is also modulus related. I go in first one. Students, every modulus value known always non-negative. Yes, we know that. Every modulus value, interval any numbers are greater than or equal to 0. And in that I just 1 subtracted. So students, I just here 1 subtract. That also 1 subtract. It means x plus 2 minus 1 is greater than or equal to minus 1. That value is what? It is your fx. Yes, students, your fx data. Easily you can plot on the number line here minus 1. And going to greater than sides, it means improving your right hand side wing. Yes, students, you can check your graph going to right hand side. So minimum value minus 1, but maximum we cannot say. So fx have, yes, fx have minimum value minus 1, but maximum value does not exist. Now students, at which place the minimum? I just going to here taking 0. So in fx, I just applying modulus x plus 2 minus 1. We taking this term equal to 0. Yes. You easily define at which place x is equal to minus 2. And again putting here, and you easily cover your answer minus 1. So these are minus 1 cover. To at which place x is equal to minus 2. So my answer is finally x is equal to minus 2. F of minus 2 is equal to z minus 1 is your which value? Our minimum. Yes, is minimum value. And here students, you are happily your first question is done. Now continue students, question number 2. The second factor is given gx, modulus of x plus 1 minus outside plus 3. Same explanation. We know that, what you know, every modulus is greater than or equal to 0. But outside minus, you just minus apply that with the modulus. It is less than or equal to 0. Now created. Yes. So minus of x plus 1 plus 3. Indirectly your fx being less than or equal to 3. Students, you also check my drawing. That's your number. 3 to less than. It is below sides, this size. 3 to number going to left hand side. In that way, your drawing is covered. 3 to less, it means minimum value. Yes, minimum value we cannot say. Maximum 3, minimum does not exist. So, fx have same explanation. Fx have our 3 is what? Maximum. Yes. fx have maximum value is 3, but minimum value does not exist, because we cannot say where this graph is stopping there in the minimum number. That's why. Now, after that same explanation, yes, in fx, my fx data is a modulus x1 plus 3 minus 1. We taking students x plus 1 is equal to 0. Here just we take x plus 1 equal to 0. So what is your x? Yes, minus 1. And this minus 1 you successfully putting there, then you can get number. Yes, f of minus 1 is equal to 3. And that number is actually already plot on the drawing. So students, f minus 1 equal to 3, and that's why I write down at x is equal to minus 1. F minus 1 equal to 3 is what? It is a maximum value. Yes students. Here it is maximum value and your minimum value does not exist. Yes students, I hope you understood that time numerical. Here we cannot take derivative, because modulus we can control that in derivative parts. Yes, now I am going to make. Now continue students, question number second, the third one, fourth one and fifth one. All are very easy. First of all, sin 2x plus 5. So what is the range of sine function? Yes, close bracket minus 1 to 1. So I start the number with the minus 1 to 1 and my function is sin 2x over plus 5 adding. So minus 1 plus 5, here also plus 5 and that also plus 5. So students, you getting a 4 and that is 6. It means your drawing is ready. You have to number 4 to 6 between us, and the between all data coming here. So minimum 4, maximum 6, total range is 4 to 6. So students, here fx have minimum value. Yes students, minimum value is equal to 4 and maximum. Yes, maximum value is 6. Now next one. Same question, sin 4x plus 3, but given in modulus. Modulus means positive value, either 0. So students, here also I say going minus 1 to 1, my sign range. Now plus 3. So added plus 3 in each term. Here plus 3 added, sign same here plus 3 added, and that also plus 3 added. So you getting here 2. That's same as, and that is 4. Now 2 to 4, you number take in the modulus. They are nothing changed. Your data is as it is in 2 to 4. If you negative number present, then you convert it positive. But it is already positive. So my answer is 2 to 4. Between is all data coming to that is all our values in 2 to 4. So students, my answer is easy, minimum 2, maximum 4. So fx have minimum value. Yes students, minimum value is what? 2 and maximum. Yes students, my maximum value is a 4 and here students, we easily, your question number 4 is a complete. Yes students, now same as going to fifth one. Hx, x plus 1 in x belongs to minus 1. It is a linear equation, power given. It means straight line, and straight line have no minimum, no maximum, direct code. But I am going to method wise, as the x. Students, here I am going to your rule wise, step 1. As dash x, 1 plus 0. As double dash x, 0. You cannot say it is more than 0 or less than 0. Yes. What is step 2? As dash x equal to 0 taking. But here 1 equal to 0. No, it's not possible. It means here minimum and maximum value we cannot determine. Already I told it is a linear equation. Linear equation means straight line. And straight line have no minimum, no maximum number. So here students 1 not equal to 0. So my answer is hx have no maximum and no minimum value. Here students, my this question is easily up to 50. Now continue students, question 3. Find local and global maximum and minimum values. Yes, I written 2 questions. It's very easy questions. First, fx x square. You know that students, x square is a parabolic curve. Yes. Its minimum and maximum at x square, x equal to 0. Yes. But I am going to method wise. Students, my method is what? Step 1. F dash x and f double dash x. Here 2x. Here 2 into 1. It's always greater than 0. Yes. Now step 2. F dash x equal to 0 taking. So students, you just apply 2x equal to 0. But 2 never 0. Your answer is x equal to 0. Now step 3. Step 3 is a checking. F double dash x. Put down the 0. My answer is greater than 0. So at x equal to 0, fx is local. Yes, local means it is your lines on the x-axis. Yes, at x equal to 0, fx is local. Greater than 0 means minimum. Now I go to last step. Fx. In the fx, here students, put down x is equal to 0. And you get in your answer. It's your global. Yes, it's global minimum value. Yeah, maximum value we cannot determine because it is a parabolic curve. If you know that this is your parabola, y is equal to x square. Sure, minimum is 0, but maximum they going to infinite. We cannot determine your maximum value. It's a global minimum value confirm. It is a 0 at plus 0 is value is 0. Now students, I am going ahead. Question number 2. Gx is equal to x cube minus 3x. Very easy. Same going step 1. My step 1, g dash x and g double dash x. So what is the g dash x? 3x square. Here 3. X is 1. Now here 6x. 3 is 0. Yes students, 6x is covered to maybe positive, maybe negative. Now my step 2, your g dash x equal to 0 degree. So students, my answer is 3x square minus 3 is equal to 0. Very common. You have two factors are there. Yes, 3 never 0. But here x plus 1, x minus 1. So one answer is minus 1. Otherwise, one answer is plus 1. And these two values respectively I am going to checking in step number 3. Yes, one by one I checking and place minus 1 checking after that plus 1. So my step 3, f(x) is equal to minus 1 over g double dash x. Students, my g double dash x value is a 6x. I put down there minus 1 and already find it is more than 0 or less than 0. Yes, 6 is minus 1, less than 0. So at x is equal to minus 1, gx is, yes, at x equal to minus 1, gx. If you less than, you write down it is a maximum value. So gx is maximum, I mean local maximum. And you go to direct value. What is your value? X cube minus 3x. You give successfully minus 1. And you find out your global values. Yes, it means only y-axis related. So students, here minus 1 the cube, 3 with minus 1, you get in here 2. It's your answer. Global. What criteria? here also maximum. Yes. Now your first case is done. X is equal to -1. Now I go to x is equal to 1 place. Same checking. Same step 3 and step 4. So students, I just moving ahead and the values putting x is equal to 1 now. Similarly, and x is equal to 1. So similarly I explain at x is equal to 1. Again g double dash x. So does this step I again repeat it. But that is -1. Now I take 2 plus 1. So what is g double dash x? 6x. 6 into 1 more than 0. So surely at x is equal to 1, gx is local. Yes, local what? Greater than 0 means? Yes, it is local minimum. And value is the step forward. So gx, x cube minus 3x. Students apply here 1. And you can cover happily. Your answer is -2. And that is my answer is what? It is global. Yes. It is global. Our answer is what? Minimum. And here students, my question number 2nd, happily, yeah. Now students, time coming to IMP questions. Yes, these are most IMP questions already asking in exam. Hx sin plus cos in 0 to pi by 2 related. Students, method is same. Step 1 our h dash x and h double dash x. Two derivative must be do. Sin derivative cos and cos. I have minus sin. Now second derivative minus sin and here minus cos. Now I go into my step. Yes, if first derivative equal to 0. So your first derivative cos minus sin. So what do you get? Cos x is equal to sin x. And just rearrange. It is sin by cos. Definitely it is 1. And that is what? Tan x. Now when tan is 1 in your interval is only 0 to pi. It means first quarter. Yes, definitely. Pi by 4 belongs to 0 to pi by 2. And here students, I just go into verifications in step 3. Yes, f double dash x. Sorry, h double dash x. Function given h. This is h double dash x. Minus sin, minus cos, and operate that h double dash pi by 4. And you can create the values. So double dash sin 45 1 by root 2, cos 45 is also 1 by root 2. And that value is what? Minus 2 by root 2, minus root 2 less than 0. So, and x is equal to pi by 4. Our hx is local maximum. Students, here maximum rate because it is less than 0 cover. Now my final answer, step 4. Yes, in step 4 it's very simple. Hx in the original form, sin x plus cos x. Operate here, students, like that. And you can cover your answer. Sin 45 by root 2, cos 45 by root 2, 2 by root 2. It is root 2, and that's your student's answer. My answer is what? It is global maximum value. Because already I checked here local maximum, and that's your students. Your question number 3 is also happily done. Now students, one more question. Fourth one is also very most IMP. Many time asking in our exam. So students, here also tick mark. It is IMP questions. Now method same. Step 1. Yes. What is my step 1? F dash x equal to f double dash x equal to, taking two derivative. Sin derivative cos. But what is minus cos derivative? It is plus sin. data is 10x. Now students, 10 is minus 1. Your interval is given 0 to 2 pi. It is you are here to completely move one circle. Yes. 10 negative in the second quadrant and in the fourth quadrant because all as TCYs. Now students, in the second quadrant, I derived that pi minus pi by 4. Otherwise, in fourth quadrant, 2 pi minus pi by 4. So my value is 3 pi by 4. Otherwise, 7 pi by 4. And here 2 value I checking in step 3 and derive in step 4. That's why students, these are IIT questions. Now I go to step 3. Yes, x is equal to 3 pi by 4. Checking very easy. F double dash x. Students, double negative is only and only purpose for checking. It is maximum or minimum. So f double dash 3 pi by 4 sine 3 pi by 4 plus. Now students, 3 pi by 4 means which quadrant? Second quadrant. Sine positive, cos negative 45 degree. So my data is ready. Sine 45 1 by root 2. Cos 45 1 by root 2, but it is positive, that negative. Here plus right now. Now my data is completely minus 2 by root 2, which is minus root 2 less than 0. So x is equal to 3 pi by 4. Yes, fx is local. What? Less than 0 means maximum. And finally I derive my answer. Step 4. In putting your fx only. That's my fx. Sine minus cos. Yes, students, here putting down the data. And just value apply. And 3 pi by 4. So sine 3 pi by 4 minus cos 3 pi by 4. And 345 again I gain second quadrant. It is 1 by 2. Here minus 1 by 2. 2 by root 2, and that's your students' answer, your global maximum. It is y-axis related. Yes, it is global maximum value. And now continue students. I first checking is done 3 pi by 4. Now I checking 7 pi by 4. So same application, my step 3 at the place of which one? 7 pi by 4. So f double dash x, f double dash 7 pi by 4 minus 7 pi by 4 plus cos 7 pi by 4. This is your double dash x. Now which quadrant? 4. Sine negative, cos positive. So my answer is negative 1 by root 2, positive 1 by root 2. You have to 2 by root 2. It means students root 2. It is a purely positive number. In this case, negative we define. So here local maximum we write down. Now here local minimum. So and x is equal to 7 pi by 4. Fx is local minimum. And now I am going to same step 4, putting down in your fx. This is your fx initially. Sin x minus cos x, and derived value f of 7 pi by 4. So students, here sin 7 pi by 4 minus cos 7 pi by 4. Then the value declared. You can easily judge your answer. 7 pi by 4 indirectly quadrant is, yes, here your 7 pi by 4. So that's your 3 pi by 4. Quadrant number 4. So your value is a negative 1 by root 2. Here only 1 by root 2. So minus 2 by root 2, which is minus root 2. And that place, it's the write down what? It is global minimum value. Yes, it is global minimum. Students, here numerical term, but in this interval, if you written here or equal, sometimes the written So you define also 0, define also 2 pi will be at the place of step 4. And that's after you declare what is the maximum, what is the minimum. Yes students, here question number 4 is most type numerical done here. Is overall numerical 3 marks question. Yes students, here this part also I will stop, and further explanation for this exercise related numerical I explain into next part. Okay, bye bye.